Okay, so let's begin again by looking at the experiment, one of the experiments, okay, which I think may come out in our paper 3 this year. Okay, so the first two experiments, the first experiment now, which we covered twice, okay, for both SA and ST, we covered this experiment twice, which is the Ohm's law experiment. Okay, now in the Ohm's law experiment, you are expecting to see you are expecting to see a VI graph, and it is perpendicular. It is directly proportional. Okay, but this is if it is an ohmic conductor. Okay, an example of an ohmic conductor is a constantan wire. Okay, so if it is a constantan wire, you are expecting to see that as you increase the current, you will increase the voltage will increase directly proportional. So you should get a straight line that begins from 0. Okay, that's experiment number 1, which I'm targeting. Experiment number 2, which I'm targeting, is the non-ohmic conductor. Now this one we didn't do, but the setup is the same. Okay, the way you arrange all of this one is all the same, okay, except that instead of using a constantan wire, you will use a light bulb. Okay, you use a light bulb, and the graph that you expect to see is a increasing graph. Okay, it is like a U-shaped graph lah. Okay, where the relationship will be V increases as I increases. So dia bukan directly proportional. Yes, it starts from the origin. Dia bermula daripada asalan, tapi dia naikkan begini. Okay, so it depends on what they give you on exam day. If you see a constantan wire, expect, okay, not even expect, you need to remember that it is going to be a straight line. If you see a light bulb, okay, if the apparatus you see over there, oh, okay, dia bagi light bulb, then you are expecting a non-ohmic conductor punya graph, which is a curve. Okay, so having this kind of expectations will help you to know how to answer the question. It will help you to know what kind of graph you want, and of course will help you to be able to predict the values that you want to get lah. Okay, again, remember always, okay, that you cannot memorize the values. I'm definitely not encouraging you to memorize the values, because remember, the values that you memorize, if it is not the same as mine, that's it, you know. Okay, you will lose marks for having a different set of values altogether. So no matter what the answer is, no answer is more important than my answer. Okay, the teacher who is doing the experiment, the teacher's answer is the most important. So even if you get a perfect graph, 0.1 to 0.5, 0.1 to 0.5, but your teacher gets 0.1 to 0.3, example, okay, you will be penalized for giving the wrong answer because you're not following my graph. Okay, so do not memorize the values, but memorize the pattern, because the pattern cannot change one. Okay, if it is an ohmic conductor, straight line. If it is a non-ohmic conductor, it is a curve. Okay, but the third graph, which I didn't really do the experiment, but I feel that we should cover this experiment. Okay, is the EMF experiment. Okay, is the experiment to determine the value of the EMF and the internal resistance. Okay, so in your textbook, you will see in page 118, okay, an example, a possible example, okay, of an experiment where you are this will be considered an open experiment. Means the steps you have to plan one. Okay, you have to write down the steps what do you do, what do you do, what do you do, what do you do. So this would be an example of an open experiment. Okay, and based on this one, you will ask you to record the results based on the graph, then you calculate the gradient, write a linear equation. Okay, so these are pretty standard questions, and I feel that if it is an open experiment or if it is a guided experiment, okay, you will still have to draw this. For an EMF experiment, you cannot really run very far away. Okay, so state the relationship between V and I, and so on and so forth. Okay, so this is how it may look like if it is an open experiment. Okay, Sorry, hold on. Okay, so this is how it may look like if it is an open experiment. But if it is, let's say, a guided experiment, okay, just give me a while. Sorry, the screen is... Okay, if it is a guided experiment, it may look something like this, which I've already given to all of you, those of you who came to school. Okay, so the aim is there, the apparatus is there, okay, the setup is there. You can ignore this one because it's the same. Okay, and the procedure is all given. So setup as shown, close the switch and adjust the rheostat until the current is 0.2 amps. Okay, notice over here that you're only given one battery. Okay, so in the Ohm's law experiment is usually 3 batteries. Okay, but if it is a DGE, sorry, if it is an EMF experiment, usually it's just one battery only lah. Okay, usually, okay, so you kind of want to see there are a few things that make these two experiments different. The Ohm's law experiment, you will definitely have a constant wire, you will definitely have a light bulb lah. But in a in an EMF experiment, very basic. Okay, very basic. You will only have a voltmeter, ammeter, a rheostat, a switch. Okay, and those of you who have fiddled around with our school stuff, you know sometimes you don't even need the switch lah. I'm not advising you to do that, but yeah, sometimes you don't need the switch. Okay, but the most important difference is actually the number of batteries. One battery usually will refer to the EMF experiment. Okay, and one battery is usually about 1.5 volts. So it's about 1.5 volts, okay, which is the value of the EMF lah. Okay, if you know, no, if you remember this. Okay, so I want to go through these questions, okay, because I think we didn't really go through it so much. So, you know, you have to close the switch, okay, adjust the rheostat, okay, until it is flowing in the circuit. So this procedure is given to you, okay, and I would suggest that in the coming 1 week, you memorize both experiments in case it is an open experiment. So at least you have the steps for the Ohm's law experiment and also the EMF experiment. Okay, so close the switch, adjust the rheostat until you get 0.2 amps. Okay, and just as a reminder, this 0.2 amps, okay, if it is a closed experiment, you will have, sorry, if it is a guided experiment, you will have to follow. But let's say if it is an open experiment and you yourself determine, okay, the currents that you want. Remember that you need 5 current values. Okay, you need 5 current values. So what you do is you set up the circuit. Okay, you set up the circuit and then you adjust the rheostat to the maximum and the minimum. Okay, adjust the rheostat to maximum and minimum. Look at the current values. Don't look at the voltmeter yet. Look at the current values. What is the maximum you can go? What is the minimum you can go? And then choose 5 values. When you choose 5 values, it has to be sekata. Okay, so don't go and choose 0.1 and after that 0.2 and then after that 0.4. Cannot, it has to be sekata. If you're going to go 0.1, 0.2, the next one must be 0.3. If you're going to go 2, 3, 4, 5, 6, can. Okay, if you're going to go 2, 3, 4, 3, 4, 5, 6, 7, also can. Okay, but make sure that it is even. Okay, don't skip and then don't skip, skip and then don't skip. Jangan 0.2, 0.3, and then 0.5, and then 0.6, and then 0.8. Cannot. Okay, it must be sekata. If it is an open experiment, you determine the current values. Okay, the more I think about it, for me, the more I think about it, I feel that the physics experiment will be an open experiment because it's easier for you to determine the value of the current. Then if you follow the procedure and then after that, alamak, my rheostat something wrong, I cannot go until 0.2. Okay, that's happened to us, right? Okay, when we discuss this. So I feel that because of practical okay, supaya dia menjadi sangat senang untuk semua orang, we will probably be given an open experiment. Okay, but I could be wrong. Maybe it's a guided one. Okay, so record all the data on the table. You will get these 5 data. Okay, you get the 5 data. If it is a guided experiment, then the values of the current usually are given to you. All you need to do is just fill in this. Okay, now please remember, the rules of filling in a table. Okay, number 1, there must be symbol and unit. Okay, as shown over here. Symbol is I, the unit is A. Symbol is V, the unit is V. Do you have to put the word current or potential difference? You don't have to, okay, it's not wrong, but you need to make sure that there is at least the symbol and the unit. If you put it in, it's a good bonus for you. If you don't put it in, don't worry about it. Secondly, the MV must come first, the RV must come later. Okay, the order of the table, okay, susunan jadual itu sangat penting. Okay, the table order is very important. Okay, so say for example, in the Ohm's law experiment, is I, V, and then R bahkan. Okay, so it'll be I, okay, and then V, and then R/Ohm. Okay, so manipulated variable. Okay, then the V is responding variable. Okay, and then R is whatever that you calculate. Okay, dia punya urutan mesti begitu. You cannot put the calculation first and then the MV at the back, or the RV first and then the MV at the back. Tak boleh, tak boleh, tak boleh. Okay, when you present data, you present it systematically. Okay, don't mind tembak sana sini sana, cannot lah. Okay, and then of course the third, and for me the most important one, is the decimal places. Okay, the decimal places need to be the same in the same column. Okay, so let's say for example, your current all is 1 decimal place, but your potential difference example lah. Okay, let's say here 0.12, 0.14, 0.16, 0.18, 0.2. Example. Okay, this is wrong. Why? Because everything is 2 decimal place, and then suddenly this 2 is 1 decimal place only. Okay, so you need to add a 0 behind to make 2 decimal place. But is it okay if this one is 1 decimal place and this whole thing is 2 decimal place? Okay, no problem. Okay, so you can have different decimal places for different columns, but in the same column, everything must be the same decimal place. Okay, this one is very important. And I kind of noticed that this is a skill that people may have forgotten during during the trial. So don't try not to forget all these little details. Because all these things will contribute to you losing marks. And where you can, please avoid losing marks. Okay, please avoid losing marks. All right, let's go to the questions. Okay. So this is where this discussion becomes very important because I didn't really discuss this much before Chinese New Year, and I feel that after Chinese New Year we don't have time. Okay, for the EMF experiment, when you plot the graph, you are not going to get a directly proportional graph. You are going to get this kind of graph, V against I. You are going to get this kind of graph. Okay, in fact, actually, when you plot, you will most likely get, you will most likely get a graph that is kind of like hanging at the side there. Okay, kind of like what I'm showing you soon. Okay, so you'll most likely get a graph that is hanging like this. Okay, that is kind of like halfway, and there's no pintasan or anything. Okay, when you get a graph like this, okay, EMF experiment, you need to make sure that there is an intercept. Treat this like a linear law question. Okay, it really is like a linear law question. So extend the graph all the way until you get a y-intercept. Must. Okay, must. Okay, then you calculate the gradient of the graph. Okay, gradient of the graph, 3 rules. Number 1, you need to have a triangle. Okay, and the triangle must be as big as possible. Okay, choose 2 points and then draw your triangle over there. Secondly, of course, you calculate by normal y2 minus y1 over x2 minus x1. Okay, which is the standard formula for calculating the gradient. Now, I want to remind all of you that at this stage, at this stage, in your science stream career, calculating the gradient should be very natural, should be very normal. And usually, in my experience, people will make mistakes here because of exam, okay, kehangatan exam. And then people will be like, the Y2, Y1, suddenly they forget. Okay, just be careful. Okay, I'm not saying that you should remember anything extra. I believe that you know how to count the gradient. You just have to be extra careful to make sure that you avoid all these small mistakes. Okay, something that I saw during the trial exam. Okay, and of course, thirdly, the gradient, okay, must have a unit. No unit, very difficult. Okay, what is the unit for this graph? It is the same as the unit for the Ohm's law graph. Okay, the unit for this is ohms. Okay, so whatever value you get for the in the graph, okay, for the gradient of the graph, make sure you put ohm over there. Okay, now you will most likely, because of the shape of the graph, okay, and if you can star this lah, okay, the value is negative. Okay, not to say most likely, definitely. Okay, you will definitely get a negative value for the gradient of the graph. Okay, which is because of the shape of the graph. And it's okay, don't worry about this. Okay, the shape of the graph is negative, so you will definitely get a gradient value for that is negative. Number 3, determine the v-intercept of the graph. V-intercept means this lah. Okay, referring to this. Now, if you're using one battery, okay, if you're using one battery, and if you know the concept of EMF, you will know that the V-intercept actually represents the EMF. Okay, the value that you get here should represent the EMF of the dry cell. And the EMF of a single dry cell, okay, is about 1.5 volts. You shouldn't stray too far from this value. Okay, so 1.5, 1.6 can, depending on how you draw your graph lah. Okay, the ideal answer will be 1.5. Okay, but of course, again, the ideal answer has to follow my answer. Maybe I will get 1.7. Okay, so whatever it is, follow the rule. The rule is if the if the v-intercept is 1.7, you write 1.7. If it is 1.5, you write 1.5. I'm just telling that the answer should be about 1.5 volts. Okay, because the v-intercept represents the EMF of the dry cell. Okay, if you move further down, okay, so the conclusion, okay, how do you write the conclusion? Okay, how do you write the conclusion for this? Just state the shape of the experiment graph. Okay, so in this case will be V decreases linearly. Okay, with I. Okay, V decreases linearly with I. If you look at the experiment punya this one, to determine the electromotive force and the internal resistance. Okay, that is the kehendak, that is the aim of the experiment. Okay, so we write down the value lah. Okay, the electromotive force, the EMF is 1.5 volts, and the internal resistance is, okay, the internal resistance actually is represented by the gradient of the graph. Okay, so the gradient of the graph actually represents, okay, internal resistance. Okay, gradient of the graph represents internal resistance. So when you calculate this already, okay, you will find that, okay, EMF is 1.5 volts. Again, guys, this answer depends on your own intercept. And the internal resistance value is dependent on your own gradient. Okay, so make sure you calculate everything correctly. If you calculate everything correctly, you cannot be that far wrong from my value. Okay, so that's the most important. Internal resistance is, sorry, the internal resistance is yada ohms. Okay, depending on what your graph is. Okay, again, everybody, the most important answer is not the book answer. Okay, it is my answer. Okay, and you can be very sure that I will definitely do my best to make sure that my answer is as close to the theoretical value as possible. Okay, now if we rearrange this, okay, rearrange the equation E equals to V plus IR to express V in terms of EI and R. Why do we want to do this? Because this is linear law. Our graph is what? Our graph is V against I, right? So V is our y-axis and I is our x-axis. So if I rearrange this, I will get, if I rearrange, I'll get V equals to E minus IR. Kalau saya tulis balik, V equals to, I'm just rearranging this time. The reason why I want to rearrange this is because I know that my V, okay, my V is the y-axis, okay, y-axis, and my I is the x-axis. Okay, and according to linear law, this is y-axis, this is x-axis. Therefore, your negative R is your gradient. Okay? Your negative R is your gradient, and sorry, so slow. Okay, negative R is your gradient, and your E, which is your EMF value, is the V-intercept or y-intercept, depending on how you read it. That's why calculating the gradient and determining the V-intercept is very important in this experiment, because the gradient and the V-intercept tells you two very important pieces of information. Okay, the E should be as close as possible, okay, to 1.5. And the internal resistance, okay, is negative R, which is also the same as the gradient, which is a negative value. So your R will be a definite positive value. So compare and relate the equation of V with the straight line of this one. Okay, so when you compare and relate, you will get this lah. Okay, y-axis is V, x-axis is I, gradient is negative R, and C, our y-intercept, okay, is E. Okay, y-axis is V, x-axis is I, M is negative R, and C is E. Okay, so from the equation and the graph, determine the electromotive force and the internal resistance. How do you do that? Electromotive force is the C. Internal resistance is the gradient. Okay, internal resistance is the gradient. So, you know, in this experiment, can't really run very far lah. If this experiment comes out now, most likely they're going to ask you to draw a graph. Okay, and then from the graph, determine the value of E and also the value of the internal resistance. Okay, so, you know, the value of E, as I said just now, the value of E is pretty standard. If we're using one battery, the value of E is about 1.5 volts. Okay, the value of R may change a little bit lah, depending on the battery itself. Okay, but the value of R, if you calculate everything correctly, your value of R cannot run very far. Okay, but again, remember that when you draw the graph and when you draw the line, make sure to follow the rule of best fit. Best fit rule always is the most important rule, because that will give you a better reading of the gradient and that will give you a better reading of the y-intercept. Okay, expect to see the graph like that. Don't be surprised, because that's because the reason why is because of the position of the voltmeter lah. Okay, the voltmeter's position actually helps you to know which experiment we're talking about. Okay, we're coming down to the last 11 days. Okay, there's only 11 more days before your paper 3. Okay, and it is this 11 days that is going to be very crucial lah. Okay, some of us, maybe we're still like 新年快乐. Okay, maybe we're still like Chinese New Year, it's okay. But when you go back to school on Monday, the first thing you need to think about is your Bahasa Melayu lisan, kan? Your Bahasa Melayu ujian lisan. After that is the lab exam. So space yourself properly. Okay, guys. Okay, space yourself properly. Take some time to go through the experiments and, you know, set it in your mind. Okay, I believe I've discussed this with teacher he, you know, and even the teachers in All Saints, we also kind of agree that this is where we should be focusing. It is one of these 3 experiments: ohmic conductor, non-ohmic conductor, and EMF. Okay, I cannot tell you not that I cannot tell you, but I cannot really say I don't know which one lah. I don't know which one that you should focus on. But I think out of the so many experiments in your Form 5, kalau saya boleh zoom in on 3, okay, I think that is good enough help that we can give you lah. Okay, so if you need to watch this video again after I posted up on YouTube, okay, watch this video to to understand properly how to answer the questions. Okay, doing the experiment, of course, is half the battle. Answering the questions is the other half. And it helps, it helps when you know what kind of graph to expect. Okay, daripada kau just, okay, saya buat sajalah, then tengoklah macam mana itu graph. No. Okay, in the exam, it helps to know, oh, okay, EMF experiment. So I need to know that this is the kind of graph that I should expect. And when you have that expectation, it helps you to do the experiment very, very easily. You can finish it very fast, less than 40 minutes, I guarantee you. If this is the question that comes out, you should be able to finish this in less than 40 minutes because it is just like an ADMAT's linear law question, almost exactly. Okay, it's almost exactly like the ADMAT's linear law question. Okay, you really cannot run very far. Now, let's continue. We're going to go into the SBP paper 2. Okay, and this one I only gave a digital copy because we have decided that we're not going to be able to print out this for you. Because when we print out, actually the photostat is kind of blurred. Okay, so we decided to give you a digital copy, but I will definitely want to discuss this paper. Of all the many papers, there are always two papers that are very important to me, which is the SBP paper and the Kelantan paper. I don't know why, but every year I always focus on these two papers first, okay, and then only I will look at the rest. Okay, so this is the second one. I've discussed the Kelantan one with you. I want to discuss the SBP especially, because the SBP one is a digital version. Okay, so because of this, we will discuss the structured questions as well. The objective questions, I will give you the answer after this class. Okay, if I forget this, remind me, because I'm still in Chinese New Year moon, so I may forget things after 4:30. Okay, but yes, paper 1, I will definitely only give you the answers. And as I advised you before, what you can do is copy down the answers and learn from the questions, or you can answer it first and then you compare with your answers. Okay, question number 1. Diagram 1.1 shows a spoon appearing to bend in water. Keyword is bend in water. Okay, due to a light phenomenon. Okay, so once again, please remember that there are 4 phenomena. Okay, the 4 phenomena of light is reflection, refraction, diffraction, interference. Actually, there's a 5th one, total internal reflection. Okay, so the 5 light phenomena is a very important thing. Please remember this. Okay. You know what? Let me write here. Light phenomenon 1, reflection, 2, refraction. Not just light okay, it's also wave phenomena Okay, 3, diffraction or diffraction, depending on who you ask. 4th one is interference. Okay, and the 5th and the special one, okay, is total internal reflection. Okay, and total internal reflection is very specific, only light. Okay, it only happens to light, total internal reflection. So when we see the word phenomenon, especially when it is combined with the words light phenomenon, wave phenomenon, always have this. Okay, a phenomenon is a naturally occurring event, okay, that can be explained scientifically. Satu kejadian semula jadi, okay, yang boleh diterangkan dengan menggunakan konsep sains. Okay, that's a phenomenon. Okay, so tick the correct answer. What is the light phenomenon? Wow, this is a bonus question. All you have to do is just tick only. Okay. So the light phenomenon, obviously, this will be refraction of light. Okay, the light appears to be bent. So this is the correct answer. Hold on now. Okay, so the refraction of light. So again, guys, when they ask light phenomenon, okay, there are only 4 plus 1. There are only 5 answers. Okay, even if they are not asking you to tick, if they ask you to write down, just choose one. If you know what the answer is, this one. Don't go and say, what is phenomenon? I don't know what is phenomenon. Okay, please, you've been studying phenomena since standard 1 when you learn science. Okay, don't tell me you don't know what is phenomena. Okay, state a physical quantity that changes. Okay, when light, sorry, question B, my screen is going to show up a bit slower. State a physical quantity that changes when light propagates from water to air. Okay, this is important one. That is definitely speed of light. Now complete the ray diagram to show the refraction of light that occurs on the spoon in diagram 1.2. Okay, so what you will want to do, okay, of course, the first thing you notice is that there is a straight line, okay, and it's going straight to the eye. So the first thing you want to do is to draw a dotted line, okay, following the straight line, okay, until it touches the image. That's the one lah. Okay, then the second one you draw, okay, the second one you draw is a normal line from here all the way to here. Okay, yeah, okay, so sorry, it's not very straight on my this one because I'm not using a ruler. But use a ruler, draw a straight line, okay, from the point of from the sempadan sana, okay, until the object. Okay, and that's it. This is one mark, this is one mark. Okay, because our eyes can only see light traveling in a straight line, they cannot see bent. That's why the image appears bent to us. Okay. Anyway, if you don't understand this, just remember this. The first line is a straight line, okay, directly from the eye to the image. But that one must be a dotted line. The second one is from the object to the border, okay, kepada sempadan. Okay, just draw any straight line lah, as long as it is not the same line as the dotted line. Okay, so this is the light ray. The straight one is light ray, the dotted line is what we see. That's why we can only see the straight line. Okay, so this will be 4 marks. Very easy 4 marks lah. Okay, question number 2. Diagram 2.1 shows a light transmitter and a photocell, okay, placed on an automatic fencing system. Hold on. Okay, the gate will open if the light radiation that is directed to the photocell, okay, is blocked by the car. So if the light is blocked by the car and the gate will open, okay, that's good lah, right? You don't want the gate to close when the photocell is being blocked. Okay, so over here you have a photocell. So this will, we have to remember lah. Okay, what is a photocell and how does a photocell work? And this is obviously quantum mechanics. Okay, so we want to talk about threshold frequency, and then of course the kinetic energy and the energy of the photon. Okay, so Planck's constant, all this will come into play here. Okay, so what is the photoelectric effect? Okay, so we talked very long about this actually. But the first question is that the definition of photoelectric effect. It says the photoelectric effect occurs at cathode when the light radiation is directed to it. So the photoelectric effect is, okay, that's the keywords that should be there lah. Thermionic, okay, thermionic emission is emission of electrons from a metal surface when after the metal surface is heated up. Okay, so there's 3 keywords in there for thermionic emission. But photoelectric effect is you need to have a beam of light with certain frequencies, okay, which we call threshold frequency lah. Okay, that's a normal saying. Okay, so the threshold frequency is 5.16 times 10 to the power 14. Light radiation, as I said just now, we changed to this one. So I have written out the formula, okay, on the top over here, which is HF, okay, or the energy, the total energy is equals to the kinetic energy, which is EK, okay, plus the work function, okay, work function which can calculate, which is H times the threshold frequency. Okay, so what you do is, of course, if you have the wavelength, okay, you can calculate the total energy lah, because the total energy comes from the light radiation. So first of all, you need to count the frequency. Okay, when you calculate the frequency, it will be V equals to F lambda. Okay, V equals to F lambda, and the speed of light is always 3 times 10 to the power 8 equals to F, and then after that 560 times 10 to the power negative 9. Okay, this is the total energy punya calculation. Okay, total energy punya calculation. You calculate the frequency first. Okay, by substituting the speed of light, which is 3 times 10 to the power 8, then F, and then 560 times 10 to the power negative 9. Why is it that we cannot use this as the value of F? Because this is the threshold frequency. The threshold frequency has to do with this one. Right now, I'm calculating the F. Okay, I'm calculating the F to substitute into the total energy, which is Planck's equation, E equals to HF. Okay, so we need to differentiate this. Okay, again, this is where the complication happens lah. Okay, so when you get this F value, and then you determine the value of the energy by multiplying it with H. Okay, if you have forgotten the value of H, H is equal to 6.63 times 10 to the power negative 34. Okay, then you get the total, this one. Okay, that's step number one. Okay, calculate the total energy. So to calculate the total energy, then you get E equals to HF. Okay, you get this value over here. I don't have the answer, I only have the final answer, so I can tell you the steps now. So the first step is to calculate the total energy by using E equals to HF. But you are only given the wavelength, so you have to calculate the frequency of that particular light radiation by calculating V equals to F lambda. Second step, calculate work function. Okay, work function also uses the same formula, E equals to HF. Okay, except that we represent this by W equals to H times 5.16 times 10 14 Hertz. Okay, because the work function has dia ada kaitan dengan the kinetic energy. Okay, and then finally the third one is the total energy equals to kinetic energy plus the work function. Then you can find the value of EK. Okay, I will give you the final answer. It's 1.31 times 10 to the power negative 20 joules. Okay, EK plus W. So you substitute the E, okay, then you substitute the W, you will get the value of EK equals to 1.31 times 10 to the power of negative 20. And of course, any energy is always joule. Okay, so yeah, I know we haven't done much revision on this, but just to remind you that actually quantum mechanics, quantum physics, the equations in quantum physics are easy. It's just that you need to know which frequency to use in which part of Einstein's photoelectric theory equation. Okay, this is Einstein's photoelectric theory. Okay, this is total energy. Okay, this is kinetic energy, and this is the work function. Okay, so please make sure you differentiate between these three. Okay. Now, if you have any problems calculating this, like you don't know how to get this 1.31, you can always ask me after this. Okay, question. If the frequency of the light radiation directed to the cathode is 5.0 times 10 to the power of 14 Hertz, will the gate open? So what is this question asking? Question is asking, if the frequency of the light is like this, will there be a photoelectric effect? Okay, will there be a photoelectric effect? The question is this, but look at the frequency of this and look at the frequency of the threshold frequency, 5.16 times 10 14. If you remember from our study in quantum physics, if we want photoelectrons to terhasil, the frequency of the light must be minimum threshold frequency. Okay, and if you notice that our 5.0 over here is less than 5.16, so will there be a photoelectric effect? No, there will not be a photoelectric effect. So will the gate open? Obviously, the answer will be no. Okay, no, the gate will not open. The good thing about this question is it's not asking you for a reason. Dia tidak minta untuk sebab. Okay, but if let's say the question is asking you for sebab, then you say because. Okay, because the frequency of light is less than the threshold frequency. So photoelectric effect does not occur. Okay. In case they ask for a reason, okay, in case they ask for a reason, it's always good to know if your frequency that you provide is less than the threshold frequency, no photoelectric effect. Okay, and remember, threshold frequency depends on the metal. Different metals will have different threshold frequencies. Okay, so it does not depend on the light that is shining. It depends on the metal itself. Okay, different materials will have different threshold frequencies. So don't make the mistake over there. Okay, the light you provide will have its own frequency. It must be more than the threshold frequency so that the electrons can terbebas. Okay, all right. Let's go to question number 3. I hope we can finish the structured questions now, at least the structured questions today. Okay. Hopefully the internet is not too slow. Okay, diagram 3.1 shows a circuit to investigate the conductivity of an electric component X. Okay, one look and you will know. The first question will be name the component X. Okay, this component will be a diode. Okay, diode is an electronic device that allows current to flow in one direction only. Okay, question is, when the switch is on, the bulb does not light up. So let's take a look. If I turn on the switch, okay, I connect this one. Sorry. So now if I connect to this one, yeah, current should flow like that. Okay, current flow, current flow, current flow. Then come here. Look at this. Okay, the position is not the right position. Look at the diode. Diode is not in the right position. How do we explain the connection in the diode? Diode's connection, diode, transistor, all the same lah. It's either forward bias or reverse bias. So why does the connection, why does the bulb not light up? Okay, so the answer will be the diode is connected reverse bias. Okay, that will be how you will answer the question. The diode is connected in reverse bias. Okay, the diode is connected in reverse bias, so no current will be able to flow. So question is how the connection of the circuit in diagram 3.1 needs to be modified so that the bulb can light up. Okay, one of two, don't do both now. Okay, you either reverse the diode connection, okay, or reverse the battery terminals. Okay, don't do both, because if you do both, it will still be reverse diode. Okay, so you do either one only. Okay, you reverse the diode connection or you reverse the battery terminals. You do either one of these. Okay. Okay. Reverse the diode connection, reverse the battery terminals. Either one of these will be fine. Okay. C. Diagram 3.2 shows a full wave rectification circuit. Okay, consists of 4 component X which are connected to an alternating current supply and a cathode ray oscilloscope. Okay, when the cathode ray is switched on, the trace on the screen is shown as this. Okay, so you shown here lah. Now, of course, this is the process of rectification. Okay, so in the case of this question here, okay, in the case of this question here, this is a full wave rectification. In the case of this question, okay, it is a full wave rectification. And you know this is full wave because it will involve 4 diodes. Okay, 4 diodes. So it will be full wave. Now, of course, usually the question will be how do you arrange the diode? The diode arrangement is very important. Okay, you cannot just simply draw and then, oh, okay, this is full wave rectification. There is a rule that needs to be followed lah. Okay, when we're talking about full wave rectification. Okay, so the easiest way to remember full wave rectification is to remember that the diodes must be like this way, like this. Oh, sorry, hold on. Sorry, my bad. Ha ha ha. Sorry, like this. Yeah. Okay, it'll be up, down, and down, up. Sorry, not this one. Okay, it'll be up, down, and down, up. So how do I arrange this? I draw the triangle like this, and then down, and then this is down, and this is up. Okay, so up, down, down, up. Okay, this way and this way. Actually, there are a few ways to to arrange this lah, but this is how I remember diamond shape lah. Okay, up, down, and down, up. Some people they like to remember it this way. As long as the opposite side is the same direction. Yang ini sama arah. Okay, some people will remember it this way. And then the green color is the same direction, and then the blue color is the same direction. Yeah, some people can also do that if you want. Yeah, it's not wrong. You can also choose to do it that method. Okay, sorry, it's coming. Okay, so the green color ones in the same direction. Okay, and the blue color ones are in the same direction. So either way you can. So this is full wave rectification. Involves 4 diodes. Okay. Now just to recap, the other kind of rectification is a half wave rectification. Okay, half wave only involves 1 diode, and the oscilloscope one, the CRO, will look like this lah. Okay, it will be half, 0, half, 0. That is okay, half, 0, half, 0. So this is half wave rectification. Okay. Sorry. On the CRO, it will look like this lah. It will be half, 0, half, 0, half, 0, half, 0. Full wave, it will be half, 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 half. Okay, full wave. Okay, and usually if there's a rectification question, okay, tidak boleh lari ini kan, dia mesti tanya satu lagi lah, if you connect a capacitor, okay, which is the next question. Okay, if you connect a capacitor parallel to R2, okay, you sketch the trace. Okay, that will be shown on the CRO screen in diagram 3.3. Sorry, hold on. It's not that much better actually, but it's better than just now. Okay, so in this case, what I would do is I would follow the original drawing first. So the full wave rectification, okay, if you can see, it's like this, right? It's one. So this is the center. So it's 1, 2, and then 1, 2. So I will follow the original one first. So I will draw this lah. Except that I will make it dotted line. Okay, so instead of full, I will draw dot, 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 dot. Okay, something like that, dotted. And what I would actually draw for full, okay, will be because a capacitor, what a capacitor does is that it flattens out this one, right? So I will draw something like this. Here, go up, here, go up, here. Okay, hold on, it's coming. The red color sign is coming in a while. So this is what I will draw. Okay, so the blue one represents the original full wave rectification. The red one, okay, represents after you put the capacitor. Okay, and how do I get this pattern? How do I get this pattern is if I sambung a capacitor like this, okay, parallel to R2. Okay, how do I get this one? Okay, I mean, in case this question comes out, okay, they show you the pattern and then they ask you to add the component. So this is where you add the component in. Okay, look at the R2, the resistor R2 over there, you add the capacitor inside. The capacitor looks like a battery except that the two lines are straight. Okay, so just to remind you, battery is this. This is battery, dry cell. Okay, this is a battery, but capacitor is like this. Okay, the line is same length. Okay, capacitor. The line is the same length, and so the capacitor is the one that you want to add. Okay, to make a full wave rectification flatter. Okay, this connection is really testing my patience, but okay. All right, let's go to question number 4. Okay, question number 4. So diagram 4.1 shows a process of nuclear reaction that takes place in a nuclear reactor. Okay, so this is obviously a chain reaction. Okay, so you can see over there, this chain reaction, and this one is the big one gets hit by a neutron and then splits into two. So this particular process is nuclear fission. Okay, fission. Fission means to split it up. Okay, if you combine it together, it's nuclear fusion. But this particular question is asking for nuclear fission. Okay, so name the nuclear reaction. Okay, so you've got this nuclear fission. Okay, there are only two, fission and fusion. Fusion is you mix two together. Fission is you split one big one to become two small ones. Okay, this one is nuclear fission. Okay, now the next question is write a nuclear equation that represents the that occurs in diagram 4.1. Okay, so I'm going to zoom out a little bit so to be able to show. So this is before and this is after. Okay, after, this is before. Oh, interesting. Only two neutrons. Okay, so we have to follow the reaction. Okay, very closely. Before is only one neutron and the uranium. And then after, okay, after is two neutrons. Okay, usually we are used to three neutrons, but in this case it's two neutrons and two side products. Okay, let's take a look at this. So how we write this? 23592U plus neutron 0 and 1. Okay, that's before. Then after the fission, okay, it will become, okay, after the fission, it will become strontium 9438 plus xenon 14054, okay, plus two neutrons 0, 1, M. Okay, so one neutron will produce two neutrons after nuclear fission. Okay, but there are of course other side products also, strontium 94, xenon 140, and also two neutrons. It should be 1, 0. Sorry, my mistake. 1, 0. Yeah, neutron is 1, 0. I was like, why is it 0, 1? Sorry, 1, 0. Because that will make it seimbang sudah. Yeah. Okay, it'll be 1, 0. My mistake, sorry. Okay. Next question. Based on the nuclear reaction described, calculate the mass effect. Okay, so when we calculate the mass effect, we have to look at before and then after kita tolak. Okay, so before is 1 uranium and 1 neutron. So 235.04395 and then 1.00867. So the total will give you, okay, you calculate this lah. And then after that, after, according to this, is 1 strontium, 1 xenon, and 2 neutrons. So one xenon is 139.9216 plus 93.9154 plus 2 neutrons. So 1.00867 times 2. Let me add this together. Okay. You will always find that before and after, there's a small difference there. Okay, that's why there's so many decimal places. Okay, jangan pergi bundarkan awal. There's always a lot of decimal places involved. And there's a small difference there. Okay, and so when you calculate this, you will find out that there is a mass defect or mass difference. Okay, is before minus after. Okay, so you will get around 0.19828 ANU. Okay, the unit is ANU. 0.19828 ANU. But the question is asking you to change to kg. Okay, so how to change from ANU to kg? Okay, is to multiply the mass of one electron times 1.66 times 10 negative 27. Okay, so you will get the answer 3.291448 times 10 negative 28 kilogram. Okay, 3.291448 times 10 to the power negative 28 kilogram. Lebih kurang lah. Okay. Okay. Now, if you notice that when I calculate this question, I don't leave out any decimal place. Okay, asal tidak bundarkan awal, saya ambil semua tempat perpuluhan, and this is a very important practice. Okay, because when we talk about the mass defect, okay, the value is so tiny. Look at this, 3.291448 times 10 to the power negative 28. Imagine how many zeros are in front there. 0.000000. The mass defect is very small, but it is there. Okay, but it is there. And that mass defect is the one that you use to determine the energy by using the formula E equals to mc squared. So the m you take from here, c value is 3 times 10 to the power of 8, which is the speed of light. Okay, and when you calculate, you will get 2.9623 times 10 to the power negative 11, and the same thing now, the unit for all energy is always, and always will be joule. Okay. Now notice that in question 3 and question 4, especially question 4, question 3 and question 4 seem to be a calculation question. Just now, question 2 also is a calculation question, right? Question 2, 3, and 4 is a calculation question. So we expect to see calculation questions in number 2, 3, and 4 in the real SPM. Okay, question 5 and 6 will be comparing questions. Question 7 and 8 will be, the paper 2 other kind of questions, okay, which we will see in a little while. Okay. So this last question, not to say last. So diagram 4.2 shows a cross-sectional area of a nuclear reactor. How do you control, okay, the nuclear reaction? There are two ways to control. Okay, one is by using the control rod. Okay, and then the other one is by using a moderator. But the question is not asking just how you control. You need to also explain what the control rod does and what the moderator does. Okay, so the control absorbs the neutrons. Okay, that's one now. The moderator is used to slow down the neutrons. Okay, and this is extra information, not really the answer to this question, but just so that you know, okay, you know that for control rod, we use boron, and if I'm not mistaken, is cadmium, and moderator is we usually use graphite. Okay, in case they ask, what are the materials that are suitable for control rod and for moderator. Control rod will be boron and cadmium, and then moderator will be graphite. But the function of the moderator is to slow down the neutrons, And the function of the control rod is to control the number of neutrons, okay, by absorbing the extra neutrons. Okay, because if you look at this diagram, okay, when a chain reaction happens, sorry, okay, when a chain reaction happens, you have this neutron here and this neutron here. So this neutron goes to here, this neutron goes to here. Okay, and then after that, when the energy is released again, you produce another 2 neutrons each, 4. Okay, so you kind of want to control the neutrons that are being released. So you absorb some of them, and then the ones that are not absorbed, you slow them down so that they don't move too fast, okay, causing too many reactions. Okay, so that's the this one, okay, for the control rod and for the moderator. Okay, question number 5. Okay, 5.1, 5.2 show 2 toy cars that are remotely controlled using radio wave, okay, from their respective controllers. Okay, so if you take a look at here, this is the distance and this is the frequency, this is the frequency. Okay, now when we hit question 5, everybody, okay, when we hit question 5, you expect to, okay, soalan perbandingan, comparing question is coming up. Okay, so be ready to compare, and lepas kamu compare, nyatakan dia punya hubungan. So the first question, underline the correct answer. The speed of the radio wave is smaller, equal, or bigger than the speed of light in the air. Okay, now when we talk about radio waves, we need to remember that radio wave is an electromagnetic wave, and electromagnetic waves all move with the same speed, which is the speed of light. So this is equal to, okay, because radio wave is an electromagnetic wave. Okay, all electromagnetic waves move at the speed of light, which is 3 times 10 to the power of 8 meters per second. Okay, jangan tertipu. Don't say, oh, radio is sound. So sound is slower than light. Okay, bunyi adalah lebih perlahan daripada cahaya, which is true. But this is not talking about this is not talking about sound wave. This is talking about radio waves. Okay, radio wave is part of the electromagnetic wave. And all electromagnetic waves move with the same speed, which is the speed of light, okay, in air. Now, observe diagram 5.1, 5.2. First thing they ask you is to compare. Okay, again, I mentioned again, number 5, number 6, you expect to see a comparison question. Compare the frequency, okay, of this one. This one very easy lah. One is 2.7, one is 4.9. So obviously A is less than B lah. Okay, and I don't think I need to mention this again and again lah. Kan berapa kali saya cakap ini. Please make sure you write this in full sentence. Okay, either that or 5.1 is less than 5.2. Suka hati kamu lah, kamu mau guna A dan B atau kamu mau guna 5.1 and 5.2. Okay, either one is okay. Okay, take the correct answer. Toy car A still can be controlled even though its distance is 80 meters from the controller, or toy car B. Okay, when you look at this, okay, obviously B is the correct answer lah. Okay, it's a no-brain one. No need brains also, you can see one. Toy car B still can be controlled even though its distance is 80 meters from the controller. The key here is this 80 meters. Okay, and yes, I know some of you who are extra smart will say, oh, this question now only shows 60 meters, so it doesn't tell me that 80 meters. You know, if you look at the toy car A, does it mean that the 80 meters cannot? Okay. Sorry, hold on. Does it mean that the 80 meters cannot? You know, they say, yeah, it may be that it can or cannot lah, but you don't know for sure. But toy car B, very obvious, you know, you can see for sure that 80 meters, the toy car can still move. Okay, so why would you want to be smart, Alec, and say, oh, 5.1, there is a possibility, when 5.2 is so obvious that 80 meters already can. And so yeah, in the exam, it's not the time to be a smart aleck lah. Okay, things that are obvious, don't make things more complicated than it already is. Okay, don't say, oh yeah, but 5.1 got possibility. Got possibility. You can check it out after SPM. Okay, during SPM, let's just focus on the question. Okay, no need to be so smart, Alex. Okay, okay. Calculate the wavelength of the radio wave. Okay, emitted by the transmitter of controller A and controller B. Now, this is V equals to F lambda. They are asking you to calculate the lambda lah. Okay, so lambda equals to V over F. And again, radio wave, radio wave all has the same speed. V is equals to 3 times 10 to the power of 8. So you can calculate the wavelength on their own. Okay, so for toy car A, the wavelength is about 11.11 meters. And for toy car B, the wavelength is about 6.12 meters. Okay, you just calculate, use the frequencies given in the picture. Okay, and then calculate the wavelength. Okay, V equals to 3 times 10 to the power of 8. Okay, so based on your answer in C, state the difference between the wavelength of the radio wave by the controller A and controller B. Now again, everybody, question number 5 is a comparison question. Okay, so when you state the difference, you also state it in a comparison manner, even though it's different. Okay, so I will say controller A has a bigger wavelength than controller B. Okay, state the difference between the wavelength. Don't say the difference is 4 point something something meters. No. That's not what this question is asking for. Okay, the question is asking you to compare, because this is question number 1, this is question number 5. Okay, question number 5 and 6, you need to expect that it is most likely a comparison question. Okay, it's most likely a comparison question. So even if the question says state the difference, write your answer in a comparison manner. Okay, A has a bigger wavelength than B, and so on and so forth. Okay, question E1, relate. So, after you compare, we always relate. How do we write relate? The bigger the smaller the smaller the smaller the. Up to you lah. Okay, so in this case, relate the frequency and the maximum distance of the radio wave that can be detected by the antenna. This is a no-brainer. You see that the frequency is small, the maximum distance is small. Frequency is big, the maximum distance is big. Okay, so how will we write this? Okay, the bigger the frequency, the bigger the maximum distance. Okay, dot. You can finish the whole sentence. Okay, the bigger the bigger the. Okay, and I want to remind you all once again, remember this is a paper 2 question. Okay, paper 2 question, you are comparing observations. You're not drawing graph. So don't write directly proportional, inversely proportional, because proportions are based on graphs. Okay, directly proportional is based on graph. Inversely proportional is based on graph. When you're in the paper 2 paper, write your answer according to observation. You have already compared, oh, bigger frequency, so that means the traveling distance is further. Okay, so the bigger the frequency, the bigger the maximum distance it can be shown. Okay, and again, also remember when you write the relationship, make sure the order is correct. Frequency affects the maximum distance, not the maximum distance affects the frequency. Okay, state the relationship between the frequency and the wavelength. Okay, so this one will be. Now, when we do this, okay, remember, again, I said question number 5 and number 6, we are expecting comparison questions. Okay, we're expecting comparison questions. So, set your mind so that, okay, number 5, number 6, comparison. Okay, you don't have to answer question number 1 first. You can always skip to question number 5, and start answering question number 5 and number 6, especially if you know that you are good in comparing and stating relationships. Okay, very important. All right, let's look at question number 6. Question number 6 is a electromagnetism question. Diagram 6 shows a multi-tap transformer. Okay, multi-tap means you can connect D and E or D and F. Okay, multi-tap so you connect two ends, then you, depending on how many you want. If you have more lilitan, then your coil will be much bigger. Okay, and then you're given all this information over here. Oh, look, there's an empty space, which you will probably need to fill in a little bit later. But let's read the question first. What is the type of transformer shown? There are two types of transformers, which is step-up transformer, and the other one is step-down. Okay, in this case, you can clearly see one is 1000 and the other one, oh sorry, one is 240, the other one is 60. Okay, one is 240 volts, the other one is 60. Since the voltage, the output voltage is going down, so this will be a step-down transformer. So, you're given the primary coil is 1000. You're given the secondary coil is primary voltage is 240. Secondary voltage is 60 for the whole thing. Okay, for the whole thing is 60. So you can actually find the total number of this one. The formula is Vp over Np equals to Vs over Ns. Vp over Np, Vs over Ns. You calculate, you will get Ns equals to 250. So this whole thing here is 250. Okay, when you calculate everything, Vp over Np, okay, equals to Vs over Ns. Substitute everything in. Sorry, screen today is very slow for some reason. Okay, get Ns equals to 250. The whole thing is 250. Now, since DE is 200, you immediately know that NEF is 50. This is a no-brainer. So NEF is 50. Okay, and since you know that the total voltage is 60 and this is already 48, you can know that this is 60 minus 48, which is 12 volts. Okay, it's not a very difficult calculation, just a matter of plus minus only. Okay, so NEF is equals to 50 and VEF is equals to 12 volts. Ini adalah sangat lambat. Kejap. Maybe it's my tab. Maybe it's my tab. Okay, let's go back. So this is done. Okay, determine the values. Now, compare. What did I say? Question number 6. Okay, compare. Compare NP, NDE, and NEF. Okay, so now if you're going to compare three things, then you will have to compare, you have to kind of like arrange them. Okay, obviously NP, okay, the number of coils are NP is how many? 1000. NDE is 200, NEF is 50. 1000 is more than 200 is more than 50. Okay, so you can say that NP is bigger than NDE and NDE is bigger than NEF. Okay, this is a good enough answer. NP is bigger than NDE and NDE is bigger than NEF. So you're comparing three things at once. Okay, and by writing this, automatically everybody will know that NP is bigger than NEF. Okay, tak payah fikir. Okay, compare the ratio. Okay, the ratio of VP to VS and NP to NDF. Okay, VP to VS and NP to NDF are the whole thing. Okay, the ratio. Now, if this is a ratio and this is a transformer question, the ratio will be the same. Okay, VP to VS and NP to NDF, the ratio is the same. Okay, that's why we have this formula. Vp over Np equals to Vs over Ns. That's why we have this ratio, Vp Np equals to Vs over Ns. Because even when you shift it around, saya bawa Ns pergi bawah, Vp pergi atas kan, I will get the same result. Okay, Vp over Vs, the ratio is the same as Np over Ns. Okay, NDF. So the ratio will be exactly the same. Now compare Vp, Vde, and Vaf. So using the same comparison just now, we will get the same this one lah. Vp is bigger than Vde, and Vde is bigger than Vef. Okay, so this one is if you're comparing three things. This one comparing three things. Dia jarang ditanya lah, tapi there is a possibility that it can be asked. Okay. Now, based on your answer in 6C, okay, nyatakan or state the relationship between the number of turns of the coil and the value of the voltage. Okay, the relationship is pretty much the same now. The bigger the number of turns, the bigger the voltage. Okay, so number of turns bigger, voltage also bigger. Okay. Now question, if the power supply in the primary coil is replaced with a direct current power supply, what is the value of the current flow in the secondary coil? Which means that if I change this power supply to DC power supply, if I change the power supply to a DC power supply, DC power supply, what will I get a value of reading? Sorry, okay, this will be, obviously it will be 0. Why? Why is there this one? Because transformer can only work with an AC power supply. Transformer works based on the principle of electromagnetic induction. And electromagnetic induction can only happen if there is a magnetic flux being cut, or if there's a change in the magnetic field. If the current is a direct current, there is no changing magnetic field because the current is flowing in one direction. So the magnetic field also flow in one direction. There's nothing to cut the magnetic flux. Okay, so in case people ask why, okay, so transformer can only function by using AC, okay, alternating current power supply. Okay, transformer can only function using an AC power supply based on the principle of electromagnetic induction, blah, 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 blah. Panjang sudah lah, kalau saya bagi mau jawapan penuh. Okay, but that's where we are at now. Okay, let's try to finish until question 8 now, then we'll call it a day today. Then the next session, we'll do the 3 essay questions, and then we're done with SPP. Okay, diagram 7 shows an athlete spinning a hammer in a hammer throw sport event. Okay, so the centripetal force acting on a hammer when rotated is the tension of the string. So what is the centripetal force? Okay, centripetal force is a force lah. Okay, a force that makes an object to follow a circular path with a direction that is always towards the center of curvature, or the center of the circle also can. Center of the circle is better. Okay, so centripetal force is a central force lah. Okay, that makes an object follow a circular path. Okay, but the direction is always towards the center. So in diagram 7, mark the direction of centripetal force. the direction of the centripetal force will be this way. Okay, it is always, this thing is going to go around now. So the direction of the force is always towards the center of the circle. Okay, towards the center of the circle, which is where the guy holding the hammer is. Okay, so that's the reason. Okay. Now, the hammer of mass 4 kg is rotated in a horizontal circle of radius 1.6 meters with a linear speed of 25 meters per second. Calculate the centripetal force. Formula for centripetal force I have given here, but it may not be given in the exam. So please remember that. Okay, so centripetal force is mv squared over r. Okay, you substitute m, you substitute r, you substitute v. V is given 25. Okay, and you should get the value of about 156.2.5. Okay, lebih kurang lah. You get the answer 156.2.5 newtons. Okay, so the formula is given, well, the formula I give you lah. But generally, the formula given in the front of the paper 2 is designed to help you. Okay, I've not yet seen a formula except the more popular ones yang tidak diberi langsung lah. Okay, so if you're stuck and you don't know the formula, try to look to the front. There may be clues there to help. Okay, this is question number 7. Question number 7 is membuat keputusan terbaik, making the best choice. Okay, so we need to analyze the table and so on and so forth. So based on the specifications in table 7, okay, state the suitable characteristics of the hammer throw that has the highest rope tension when it is rotated. Okay, so let's take a look. We have the length of the steel string, either 1.85, 1.55, or 1.15. Okay, so which one do we want? I would say that we want the string to be short. Why? Because when your string is short, okay, you get a centripetal force that is high. Yeah. High centripetal force. How you know it's high? Look at the formula. If the R is small, okay, if the R is small, the centripetal force is high. If centripetal force is high, it's easier to throw out. Okay, it's easier to throw out, it's easier to throw further. Okay, because you don't waste so much energy trying to move it around. Okay. Secondly, the linear speed. The linear speed when it is rotated. 24, 20, 29. Now, if you look at the formula, if you want a high centripetal force, you want to have a big linear speed because it's directly proportional. Okay, so big linear speed so that you can have a high centripetal force. You can use the same reason, okay, for both of this one. So that's your answer lah. So the length of the steel string, again, remember, do not write the number. Write bigger or smaller, higher or lower. Okay, do not write the number. I know we want to use 1.15, but we use the length of the steel string is small. Okay, small length. Okay, higher centripetal force. And the same thing for the linear speed. Okay, don't say, oh, I want 29. Okay, because of course the choice that we're making is 29. But when we're given numbers, dalam soalan membuat keputusan, guna perkataan higher or lower. Okay, I know we want 29. So we say high or bigger lah. Okay, bigger linear speed. Okay, use a bigger linear speed. And the reason for the bigger linear speed is so that you can produce a higher centripetal force. Okay, higher centripetal force. And then with that, you find that based on your answer in 7D, which hammer throw has the best? Then you answer H. No need to give reason because this is not section B question. Okay, so just say the best hammer throw is the one that has H. Only in section B Okay, the 10 mark question, that one that you have to give reason. The one that I balik-balik saya cakap, siapa yang tulis because it fulfills the characteristics above kan, terus saya bagi kosong itu. Then you find the H. After you analyze the table, oh, H is the best. Okay. All right. Last question. Last question of the day, and then we'll call it a day. Okay, so diagram 8.1 shows an airplane. When I saw this question, I thought, oh, this is a very interesting question. I think we need to discuss this. Okay, cabin altitude, which is 2134 meters. Okay, so it is about that. Now, when it is at a cruise altitude of 10973 meters. Now, take a look at the pressure. Okay. Take a look at the pressure when it is at cruise altitude and at cabin altitude. That means inside the plane has a higher pressure than outside the plane. Okay, and that makes sense because the higher you go, there's less air. Less air means less air pressure, less atmospheric pressure. So the pressure outside is much less. Of course, it's colder and blah, blah, blah. But I'm just saying that the atmospheric pressure drops outside. But inside the cabin, the air pressure is still the same. And that's good for us because we're in the plane, right? You know, when there's less air pressure, it means that there's less air. Less air means you'll be very difficult to breathe. That's why inside the cabin must have a higher air pressure than outside the cabin. Okay, and also it makes sense if inside the cabin is lower air pressure than outside the cabin, then we're going to find out that we're going to be compressed because outside pressure is going to push in. Okay, so when the inside pressure is higher, the pressure will push the airplane, further out. Okay, so so it's stronger blah blah blah. Okay, I thought this was a very interesting question, and I think when I saw these two values, I was like, oh yeah, actually that's very true. Inside the airplane, air pressure is very high compared to outside. When you're in the air, when you're on the ground, it doesn't matter anymore. Only when you're in the air. Oh, sorry. So define atmospheric pressure. Okay, atmospheric pressure. Sorry. Okay, atmospheric pressure is pressure due to weight of air. Okay, weight of air acting on the surface of the. So weight of air, weight of the layer of air acting on the surface of the earth. Yeah. Okay. Now, how might the human's rate of breathing change at high altitude? Okay, explain your answer. So, again, guys, this is nothing to do with the plane. Just talking generally in high altitude. Okay, so when you're going to high altitude, your rate of breathing, will it increase or decrease? Of course, it will increase. Okay, why would it increase? Because, okay, at high altitudes, okay, think about it. When you go higher, there's less air pressure. Less air pressure means less air. Less air means you need to breathe more in order to get the same amount of oxygen in. Like for us, if like on normal ground, we take a deep breath, wow, we get a lot of oxygen. But when we go into higher altitudes, we go climbing up Mount Kinabalu, for example, you take one breath of air, you don't feel full, You don't feel like you have enough oxygen. Because even though you're taking, a lot of air, but actually not a lot of air is going in because there's very little air. So to compensate for that, okay, you need to breathe more so you can get more oxygen in. Okay, so at high altitudes, okay, atmospheric pressure decreases. Okay, atmospheric pressure decreases. Okay, and amount of oxygen decreases also. Okay? When there's less atmospheric pressure, there's less oxygen, so you need to breathe more. Okay, you need to breathe more in order to get the same amount of oxygen so that your body can function. Okay, all right. Now, okay, let me quickly finish this. Okay, most commercial jets that are enter the jet engines to provide air to the cabin during flights as shown in diagram 8.2. Okay, so the air enters in here and then goes into the airplane and etc. 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 Okay, so the air is then processed, cooled, and finally piped into the cabin. So the pressure in the cabin is kept between 75.8 and 82.7 to ensure that the passengers and the flight crews can breathe easily. Okay, so the pressure inside the cabin must be high so that we can breathe easily. Otherwise, every time you fly the plane, everybody will be like, because there's not enough oxygen in this one. Okay, so cabin pressure, the word cabin pressure, okay, whenever the next time you go on a flight, when you hear the words cabin pressure, remember that it is an important thing. Okay, it's important to keep us alive so that we have enough oxygen to breathe. Okay, now what is the method that can be done to ensure that the passengers of the airplane get enough air? Okay, enough air at high altitudes. Okay, so this one is a bit out of the normal kind of question now. But if you think logically, if we want enough air to come in, okay, we need to be able to increase the air suction. Okay? Sorry, there. Most commercial air enters the jet engine. So we need to be able to suck in more air. Okay, so we increase the rate of air absorption. Increase the rate of air absorption through the engine. Okay. Increase the rate of air absorption through the engine. Sorry, the engine. Okay, because the air comes into the engine, the fan makan dia sedut udara lah. Okay, so kita tambah itu kadar sedutan udara masuk ke dalam engine. Okay, and the reason is to provide more air into the cabin. Okay, you suck in more air, then you get more air in the cabin, so that you can maintain the air pressure inside. Okay, now suggest an action to be taken if there is a passenger suffering from a lack of oxygen absorption, okay, in his lung during the flight. Now, this one, if you have been on an airplane before, it does help lah. Okay, I'm not saying that it does not help, but if you've never been on an airplane and you're like, what if somebody is suffering? Usually, even on normal Earth lah, if somebody is like, what do? We provide him a oxygen tank, kan? Okay, so we provide or use lah. Okay, use an oxygen mask. Okay, so planes, they will usually have an oxygen mask in case the cabin pressure becomes too low. Maybe the fan is not working or something happens that reduces the cabin pressure. Okay, so they will turunkan the face mask, the oxygen mask, so that we can breathe. Okay, and it is not meant to make us kanchiong or meant to scare us or we're going to crash. No lah, it's just to give us more oxygen so that we can breathe better. Okay, so we use an oxygen mask, okay, to supply oxygen, okay, to supply more oxygen to the passenger. Okay, just give me another 4 more minutes and I'm going to be done. Okay, this last question. This is by far the most interesting question now, which is why I really wanted to discuss. Think about this. Now, diagram 8.3 shows a side view of an airplane. Okay, window design proposal. So this is inside the airplane, this is outside the airplane. And look at the two designs. One is straight, one is curved outside, and one is curved inside. Okay, tick the correct design. to create a safe pressure difference between the air inside and the air outside the aeroplane. And of course, you say why. Okay, now, because of lack of time, I'm just going to give answer. This is, of course, the best answer. Because remember that inside the aeroplane, the pressure is high. Outside the aeroplane, the pressure is low. So we don't want this. Okay? Because if this happens, the plane is going to be, dia kena tolak lah. But if we are giving the shape like this, okay, dia punya bentuk sudah begini sedia. Okay, so the pressure is already pushing outside, so it doesn't push extra. If we do straight, kalau kita letak straight bahkan, inside the plane is going to push outside, so dia akan bengkokkan itu logam lah. Okay, the body of the plane is going to be bengkok. Okay, and logically if you think about it, airplane lah. Okay, kalau kita pandang dari depan bahkan dia punya bentuk ada bulat keluar bahkan. This is the wing of the airplane. Yeah, I know. Sorry for the ugly drawing. Okay, this is the wing. So the airplane, the shape is outside like that. So even if you don't know how to answer this, think logically. The shape of the airplane is like this. So obviously you want to have this kind of shape for the window lah. Mana ada airplane yang bentuk macam ni bahkan ni nah. If you follow this shape, the airplane will be like this. Okay, flat at the side. This is the wings. Okay, or worse, this. Okay, you have this kind of airplane. Okay, there's no window like this. So sometimes you think logically, even if you don't know what the answer is, we think logically, airplane shape is circular. Okay, because inside the pressure is higher than outside. Okay, and so when you make a shape like that, you decrease, you mengurangkan apa yang kita panggil sebagai deformation. To decrease deformation. Deformation means dia terubah bentuk lah. Okay, terubah bentuk. So to decrease deformation due to the difference in pressure. Okay, dia sudah keluar begini. So you're giving the air inside the plane more space to push out. Kalau kamu kempiskan dia punya ruang, bila udara tolak keluar bahkan, it's going to push the plane outside, and everybody's going to panic. It's like, oh, what's happening to the plane? Okay, so we want this kind of shape. Okay, so I was quite excited when I saw this paper. I was like, oh, this is a very good paper actually. Okay, anybody can answer this, especially if you've seen an airplane. You don't need to write the justification. Let's say kau tidak tahu macam mana tulis itu sebab bahkan. But when you look at it logically, of course the plane must be this shape and not this shape. Okay, because the cabin pressure inside is greater than the pressure outside. So the pressure will push it out so that you don't have to worry about the plane being kemek lah or gonna deform lah. Okay, but for our holiday session, this is it. Okay, I want to make sure that I covered the paper 3 and also some of the SBP paper with you. I will do one more online session to discuss the SBP paper with you all before we do the rest of the papers.